Welcome to Lesson 8 of Nginx Advanced Mastery, Mutual TLS. Up to now, every TLS setup you've touched has been one-directional. The server proves itself, the client takes it on faith. mTLS flips that. The client must present a certificate too, signed by a CA you control, and if it doesn't match, the handshake dies before your application ever sees the request. The whole thing comes down to 4 pieces, 3 Nginx directives, and an openssl workflow to mint the certs yourself. So here are those 4 pieces laid out. SL verify client is the switch. Off, on, or optional, where optional lets you fall back to password auth on the same endpoint. SL client certificate points Nginx at your CA bundle. That file decides who's trusted, full stop. Once a handshake succeeds, SSL client s-dn gives you the subject DN. That's your identity hook for proxy headers, authorization, and audit logs. And the 4th piece lives outside Nginx entirely. openssl, where you mint the CA, sign each client, and manage revocation through a CRL. Small config, big responsibility. Look at the 2 handshakes, side by side. Regular TLS ends with the client anonymous. The server proved itself, sure, but Nginx has no idea who just connected. Mutual TLS adds one move. The server sends a cert request, the client answers with its own certificate, and verification happens right there in the handshake. By the time your first HTTP byte arrives, identity is already cryptographically settled. No tokens to parse, no headers to trust. And here's where that handshake becomes config. 3 directives. SSL verify, client turns enforcement on. SSL client certificate points at the CA bundle you trust. And SSL verify depth caps the chain length. That's the entire Nginx side. Then you forward identity downstream with the LSL client variables, DN, verify status, serial, as request headers, so your backend reads who connected without doing a single line of auth itself. But that CA bundle has to come from somewhere, and for internal mTLS, that somewhere is you. Step 1, done once. Generate a 4096-bit CA key and a self-signed root. Guard that CA.key like a production secret. The public CA.crt is what Nginx loads. Then for every client, the same 3-step loop. Generate their key, build a CSR with a meaningful DN, and sign it with your CA. Bundle to PFX if a browser or curl needs it, and Alice is now a verifiable identity in your trust domain. With Alice issued, you verify the obvious way. Curl with her cert returns 200. Curl without returns 400. Done. But the harder question is what happens when that laptop walks out the door. You revoke against your CA, regenerate the CRL, point SSL CRL at the file, and reload. Nginx now checks revocation on every connection, and Alice is gone without touching a single client. Honestly, though, short validity windows beat maintaining a CRL. 90-day certs, rotated proactively. Let Vault or Cert Manager do the heavy lifting. Now here's where it pays off. Nginx validated the cert at the TLS layer, so it pulls the subject DN out of SSL client s.dn and forwards it as xclient DN to your backend. Flask just reads the header. No JWT library, no password hashing, no auth middleware. The backend trusts that header because it physically cannot arrive any other way. Nginx is the only thing terminating TLS, and Nginx only forwards requests it already authenticated. Identity becomes a transport layer fact. So why did finance, Kubernetes service meshes, and IoT all land on this same pattern? 3 reasons. 1. A password is a shared secret. Whoever holds it wins. A private key never leaves the client, so stealing the cert alone gets you nothing. 2. Failed mTLS dies at the handshake, before a single line of your app runs. No auth middleware, no timing attacks, no logged-in checks scattered through code. 3. Revocation is per client. Lose a laptop? Revoke alice.crt and only Alice is out. Compare that to rotating a shared API key across every consumer at 2 a.m. That principle is the why. Here's the entire how on one card. 4 directives configure mTLS. Verify client is the master switch, client certificate points at your trusted CAs, verify depth handles intermediates, and CRL is non-negotiable in production. 3 variables expose what Nginx learned during the handshake: the client's DN, the verify result, and the cert serial. Pass them to your backend with proxy.set header, gate access with if, or pipe them into log format for audit. Small surface, enormous leverage. Theory's done. Time to put your hands on it. 3 exercises, about an hour total, all on a single VM with self-signed certs, no external dependencies. First, you stand up your own CA and sign a client cert for Alice. Then you wire the Nginx directives in and prove it works with curl. Finally, you revoke Alice and watch the handshake die with certificate revoked. By the end, you've run a CA end-to-end. Before you ship this, know the 5 ways teams blow it. 1. Pointing SSL client certificate at a public CA. Congratulations, the entire internet just authenticated. 2. Using optional mode and forgetting to check SSL client verify, which silently lets anonymous clients through. 3. Committing key to the repo. That key belongs offline, ideally on a hardware token. 4. 10-year certs with no CRL, so a stolen laptop stays valid forever. And 5. A backend that trusts X-client DN without locking down who can reach it. Small config, big responsibility. These are the failure modes that bite in production. So that's mutual TLS. No password, no token, a certificate. 4 things to remember. SSL verify client on, your own private CA issuing client certs, SL client SDN as the identity your backend trusts, and either a CRL or short-lived certs to handle revocation. Small config, big responsibility. Next up, Lesson 9, ModSecurity and the OWASP core rule set, turning Nginx into a real web application firewall. See you there.